Satellite Network Advisory Group. We would like to thank the High Seas Net. We'd like to thank the um, Research SOC or OmniSOC Trusted CI sort of collection of acronyms. And I personally would like to extend a very grateful thanks to the Tech Pool for funding my time on this project. And of course, all of this, none of this would be possible without our main man, Jim Hollick, preferably or presumably in the back there somewhere. Yo, let's actually, I was gonna say like let's put our hands together for Jim, but let's actually, can we just get like a mosh pit right now, please? Um, I was actually, as this is kind of like this is a pretty cool cruise. I'm very bummed that I'm not there in person right now. I get the feeling that this RV tech is going to be an absolute ripper, and I wish you all the best. Tear it up, and can I say kick some ass on this call? All right, I just did. Anyways, with our sponsor acknowledgements and so forth, there's presumably exit signs and stuff in there. You guys should take care of that. But with all of that taken care of, I would like to say that it brings great pleasure for me to say, hello, Honolulu! And thank you for sticking around or coming here early to the Cyber Monday. I know that this is not necessarily what RV tech is traditionally about, but it really, you know, it's great to see so many people, both on the Zoom and in the room. I was a little bit, depressed when I was looking at the speaker hub and I saw there was only like 5 people who signed up, and I was like, oh man, this kind of sucks, but this is awesome. So yeah, let's get to it. Let's get this bread. I'm going renegade here. I'm actually doing this entire presentation from the ship. Uh, and I'm gonna click this one. Here we go. Microsoft PowerPoint. Yeah. All right. So, welcome to chapter 2 of The Fort Reckoning, the system design nitty-gritty component. If this was a Peter Jackson trilogy, this would be the Two Towers. So we've got the first tower, which is the, Mordor tower by the volcano of Mount Doom. So that's the shipboard component. And then we have the hub tower, Isengard. We have not yet begun to, absolutely not. I want to keep it red. Um, we got the Eisenberg card. We have not yet begun to fell all the trees, but we are making pretty good progress starting off with that. Before we get into any of this, I want to give you guys some of the background and inspiration for our little initiative here. So I saw this. I got posted a couple of months back about the some commentary on the extensive discussion we had about internet access at our VTech last year. Um, is Martech memes in the room right now? Are they on the Zoom? Is Martech memes here? All right, could somebody let them know that this is an official RVTech meme challenge? This is a throwdown. So this is become personal. I am officially extending a meme challenge for RV Tech 23 of Martech memes. I'm going to start off with some of my rebuttals here. So first off, dunking on this kind of stuff is just instantly like low priority QoS, like across the entire fleet. Again, like, oh yeah, here I am. I'm going to exempt myself from all the traffic shaping rules. That makes me a network engineer, of course. So, with the, ridiculousness out of the way, we'll begin to talk about what exactly are we proposing and presenting here. So, the real goal of this, so how we got to this system design presentation was started off with the concept of, okay, what are the problems we're trying to solve? We got some of the, cheaper entry level comparable units, went through the effort of going through, okay, we need to do this installation. We need to get an understanding of like in this system, there's going to be a hard way or there's going to be an easy way to do things, and there's going to be like 15 different hard ways to do something. So, we found a lot of the 15 hard ways. And after going through all of those, we've actually been able to get to the point where we can say, oh, okay, so these are ways to solve these problems that are easy and also some things that can be reusable. Like earlier, when we were talking about having, managing interfaces, internet connections that are not just VSAT, there's the cell, Starlink, Shorelink, what have you. So a lot of that, a lot of that process was, okay, let's start doing some projects on Endeavor. Let's, figure out what we need to do so that we can make this work, make switching over easy, and also make sure that that template is not, super locked down to anything that we're doing. Um, what this is producing is a overall like installation Bible. So that starts off with the data collection side. Let's populate our spreadsheets. Everybody's going to be a little bit different, but what we can do is we can take the unique, situation every vessel's in, and we can say, okay, well, let's bring that into the template. Let's figure out what do we have and what does it need to talk to? And then let's start, populating the templates based upon that data collection process. And let's, set up the units ahead of, ahead of time. And let's have a nice, like easy, transition process that is not just like, oh, like the crane cylinder blew. We just dropped an ROV on deck. So, we want to have it be easier than that. We want to have it be easier than like spending an entire day in the pressurized transducer well, which, believe it or not, was actually technically accomplished. Looking at we talked a little bit about in our first session here, we talked a little bit about what can we do on the ship versus what can we do at the hub sites. So what we'll start off with is the very high level overview of how is traffic normally going to flow. And the idea is that you can see our actual ship Fortigates going through this sort of meshed tunnel warp zone to either the University of UCSD campus, represented by the dude, and in the URI campus, represented by the 2020 Democratic National Convention primary, the calamari guy. The idea being that this is, there's a lot of flexibility in how these tunnels get set up. The goal is to have at least enough common threads that, you know, every institution and every ship is going to be unique. But what we want to be able to do is at least describe that uniqueness in the same overall system. And, sure, there might be some configuration knobs that are set to, 12 in one location and 7 in the other. But as long as we at least have a consistent way we can describe all of those, then it's going to make life a lot easier. And starting to look more in depth as to, what we're actually going to be installing across different locations, then that brings us to what I call the Pokeball diagram. John mentioned we were doing the Q&A about half an hour ago. We talked a little bit about being able to, with this platform, being able to create VDOMs and the benefits of, of taking your router and cutting it into virtual slices. And this is a slide that I'm going to go back to this a lot during the presentation, because really what this is showing is, okay, here's our, whole like high level overview of here's all the different kind of unique like zones or pieces of the system, and here's how they're fitting together, and more importantly, here's what problems they're solving. So the key, so how all this works is in this like overall, system, what we're looking at is we're looking at 5 different sort of like separate isolated VDOMs across 3 locations. At the bottom part here, this is where we're looking at the ship. And then on the hub west VDOM here, so this would be at the western hub and the eastern hub. The idea is, okay, we have this, for economies of scale, we've got these big, the FG 1000 series units, but they're cut into each individual slices so that we have isolation different between different vessels and different institutions. So if we are basically what's going to happen is like how all this fits together is you will certainly focus on the ship part first. So what we're looking at here is we have a single like rack mount pair of devices. In reality, it works out to a couple rack about 4 or so rack units of equipment. But you've got the FortiGates on board, and you've got your core switches. And the idea is that these are kind of divided into a triangle. So instead of having to have a bunch of separate devices that are in a daisy chain together, the idea is that we have this triangle shaped layout, and the rationale for doing that is we want to have traffic kind of baffled through the system so that when we get to the policy side of this of operating this, the idea of this process is we want to be able to make those rules simple. Like generally speaking, we're talking about the overall traffic flow, like in general, a lot of things should be able to go just on default. If we've got this like ridiculously huge matrix of rules necessary to make the system operate and comply with the appropriate cybersecurity policies, like that's not a good thing. It's generally speaking, rule structures, they should be, the default should be really powerful, and the that when there are exceptions, it should be clear and obvious and intuitive. And that's where this triangle style layout comes from. We've got everything related to the WAN and the different internet connections. That's at its own VDOM because this is also something where it makes it very easy to reuse between institutions, between different vessels. On the bottom part here, we've got the ship LAN VDOM. So if we look at like our onboard networks in general, we've generally speaking, you're going to have a pool of general unclassed, they might be public or science instrumentation. On Nautilus, we have three. We have the public Wi-Fi network. We've got we call data, which is servers and a lot of workstations. And we have a third network for instrumentation, which is mostly everything that's on the ROV. So these, I would think of these as being like the general LAN. And if we look at, so we look at the land side of this, the goal of what we're trying to show in this diagram is that we have these 5 different zones. Each zone on the land network sides, so we've got some number of different onboard networks, like on Nautilus, we've got our public Wi-Fi, the sort of servers, instrumentation. On Endeavor, there's a public network and the instrumentation network. So the idea is that so all of these are defined inside this ship LAN VDOM, but the idea is VLAN 11, 22, these are things that exist on Endeavor. So if we look at this from the very bottom up, the most basic thing that we're doing is the Fortigate's just providing DHCP DNS just so that the devices on these or the client devices on these networks are like functional. So we have all the sort of the basic like keeping the lights on services. The idea is that anytime in this you go through one of the red circles, this is where firewall rules get applied. So on Endeavor, we have Bonnie's winch logging application. So the server itself there is on the data network. It's 192.168.1, but that needs to be accessed from the public network, which is where the Wi-Fi is, and it's just kind of the general jungle-like network on board. So in this case, we've got a firewall rules, so we have the rules are being applied here. So we have a firewall policy that allows traffic to go through this circle from the VLAN 22 public network over to VLAN 11. And the idea is that if we look at the rate at which things change on the ship side, so the rollover that you're seeing on land, like when firewall rules are changing, this is generally speaking, you have new systems, new instrumentation coming online, or alternatively, rollover between cruises and changing out science parties. So a key, I think, part about making this system usable is about, thinking about what are the logical intervals that we change things? How do we group things together so that they're easy to find? The one of the things we talked about was separating the uh, general LAN versus operational technology systems. Um, this was because remember, like anytime we cross a red circle, we're going through firewall boundaries. So in this case, so we're crossing the firewall boundaries, but we also want to make sure that our default rules are really powerful. And the idea is you can see here, so if I go from, 22, I go through and I go across the diagram, because I'm going through different firewalls, um, sorry, onboard firewall instances, like that traffic flow is just going to be totally blocked by default. So this is another case of, I don't have to go through and write a huge matrix of rules because in this case, my default rule is extremely powerful. And that's where, we talk a bit about how things like, VDOMs and, it is, there is an initial sort of like curb of, yeah, it has to be set up. But the idea is that all of this sort of configuration steps is leading you to a point where the things where a lot of your overall policy becomes really effective and you can write very, abstract rules, have powerful defaults, and make it easy to, when you need to override those defaults, okay, like we can group logical things together, not have this like 500 line long spreadsheet of firewall rules. And so if we look at the onboard component, the final part we here is the ship LAN VDOM. And this is the part of the system where we look at the LAN side, so we're mostly focused on like east to west, what we call east to west traffic. There's the public network is talking to the data network. But if we look at the issues that we're focusing on the LAN side versus the WAN side, so on the LAN side, we want to make sure that devices can get on the network, they get IP addresses, they can do DNS queries and get to google.com or whatever the onboard domain names are. But on the LAN side, we need to get all these things online, but we're looking at solving very different problems in the two parts of the system. On the WAN side, we've got many different internet connections. They all perform at different performance levels, different bandwidth, different latency. All of them are going to fail at some point. They fail based upon different conditions. VSAT might go down. There might be a known issue of mass blockage. Not really anything you can do about that. There might be um, an issue with C-Link or Marlink. It might just be that the like MXPs had a stroke and everything just needs to be rebooted. You know, in the on the WAN side, we're mostly concerned with limited performance and things that can fail and making sure that it's not going to be a total maintenance nightmare to just troubleshoot and deal with broken stuff. The idea, and that's why we bring it out to its own VDOM, is because it makes it, the ship land side is going to be very specific to each vessel. Whereas in general, the land side is, it needs to provide reliable internet and we need to be able to block devices and we need to, or block internet for certain devices as appropriate. Like say on Endeavor, we have the Noble Tech Time Zero computer on the bridge. Like it needs to have internet access occasionally for updates, but most of the time it shouldn't. So, but generally speaking, a lot of the functionality on the WAN side is going to be common between vessels. So a lot of the automation and the WAN health checks and the tunneling, that's definitely something that we want to reuse. Whoops.
I'm going to interrupt you for just a second, Rachel. Yeah, could you put it into full presentation mode so we can see it all the way in the back?
Yeah, sure. Is the share still working?
Yes, yes, that's
Okay.
perfect.
All right. So there's a couple, looking at where we go from here. So there's Some of it is what we're going to talk about first is the configuration. And this is basically, these are all the steps that are necessary to, what do we need to do to get interfaces defined, get networks defined, get things plugged in. And after that, we're going to focus on policy. And then in the final bit, we'll, certainly have some time for questions. And again, I've certainly got a lot of material here, but, please do feel free to stop if you have questions. I think this is a lot of information. So, if it's going to be more helpful to have this be more of an open Q&A, we can always discuss the finer points of details at a later time. So we've got a lot of stuff to present, but please don't feel shy about speaking out and asking something, as I do like to hear the sound of my own voice, but the point of RV Tech is to be collaborative and to solve these problems together. So looking at so we've got our device configuration, and this is, we talked a little bit about the curb. So there's this curb of virtualization that we've got to make that first step. But once we make the first step, the rest of it becomes a lot easier. Whoops. So one of the first things is, and this is our HA. So the real goal here is that instead of having, cold spares where you've got, okay, here's the one that's in the rack, and then the other one is sitting in storage somewhere, and it's probably going to get lost, and the configuration's definitely out of date. Because we want to avoid a situation where somebody's got to scramble and reconfigure one. Whoops. So the idea of the HA is just we have two active units going, and in the event that one of them fails, we're not in a situation where all of this configuration has to be reloaded by somebody with like a serial terminal talking over the phone. Because we are starting with a bit more configuration, we want to protect that so that it doesn't have to be redone in an emergency. But the real biggest, I think, configuration step that's going to happen is going to be the virtualization side. And this is where we're talking about a little bit about VLANs and VDOMs. These are all virtualization tools that are, if you look at the comparison between, say, like the peplink, which is, very, very physically based. It's got, an Ethernet port, there may be a USB dongle for each internet connection, and it's got different LAN side ports for different onboard networks. These are very physically based devices. And while it's simple, it's low tech, and there's cables that you can trace. As we scale up and as we add more connections, and especially as we try and reuse effort between chips, it definitely becomes a bottleneck. So both of these look at the difference between a VLAN versus a VDOM. Basically, on the VLAN side, so VLANs exist on switches, or VLANs exist to virtualize switches, and VDOMs exist to virtualize routers. The example we had is on Endeavor. Actually, until August, we didn't use VLANs. We had separate chains of switches for the data network with the instrumentation, the CTD computer, SCS, and that was one chain of switches. And we had another chain of switches for the general public network as well as the Wi-Fi. And these are things that are, for a while it helps solve problems, but the issue is that when you've got these long chains, there was adding connectivity in new areas was a pain, and also again, like the Endeavor's a 50-year-old chip, and it's been 30 years since midlife, so just dealing with the fact that cables fail when we went through the installation process, one of the hard parts was actually you find a lot of like, oh, well, all the structured cabling in the ship, a lot of the connections are just broken. So you end up with long patch cables that go around and, you know, individual things that are easy in isolation snowball and eventually become a total nightmare. So that's where we're looking at VLANs are allowing us to take a given switch and cut it between different networks. And then on the router side, so what we could do is we could bundle those networks into different VDOMs, and that gives us a really effective set of default policies. The so far the VLANs and VDOMs are things that are immediately coming up on board. If we look at the ship to shore transport, that's where we get to the other component, the third V that we're looking at, which would be VPNs. And the idea here is that we've already mentioned tunnels a couple of times. The goal here is that if you look at what we're trying to solve here, is that okay? So a lot of if we just look at like standard 5G or Starlink or something like that, many of the traffic flows that we want to have, like bringing traffic back to a host institution or bringing it back to the hub, and none of these are going to be possible over just the general public internet. So in this case, the third component of our virtualized traffic flow are the VPN tunnels. And the advantage here is that we can we can bring we can actually we're focused on extending the ship's network to shore and most importantly not having to do NAT on the ship. So we start thinking about remote access and remote access for IT support and things like that. Being able to move that NAT boundary to shore and have this, securely managed, structured backdoor into the vessel that is going to work over Starlink and VSAT and ShoreLink and all these different connection to, tools, that is something that is going to be very helpful. And the fact that we can do all of this using standard, Starlink cellular data, that we don't need all of this like managed ISP config like MPLS and all the fancy stuff that costs thousands of dollars a month.